We'll start looking at state machines with the basic notation of state machine diagrams. We'll do this in the context of behavior state machines, and we'll start with the two fundamental elements of state machines, states and transitions, and then look at the initial pseudostate and the final state, which start and finish state machine diagrams. Behavior state machines specify the behavior of a behaviored classifier like a use case in terms of states and transitions between those states. So here on the left is the use case directly controlled device via browser, and on the right is a state machine that specifies the navigation behavior of that use case. The basic element of a state machine diagram is the state. A state defines a situation in the life of the thing being described, while some invariant condition holds. The state is shown in a round-cornered rectangle, and in this case here, the invariant condition is that the room list is being displayed. The state can also be shown with a name in a tab on the top, usually if there's some other detail inside the state that we don't want the name to be confused with. States are usually named with a capital letter. Transitions represent the movements between states, or changes from one state to another. They're shown in the diagram by an arrow with an open arrowhead going from one state to another, or to some other kind of diagram element, usually those known as pseudostates or to a final state. They're triggered by one or more events and may have a guard condition associated with them. There may also be behaviors that are carried out as a result of the transition, but before entry into the next state. This is the formal syntax from the UML specification, and this is what it looks like in practice. So here the trigger event is select device, the guard is device.class == on/off device, and the behavior is display device data. There are different types of events that can be the trigger for a transition. The example in the previous slide was an informally named event. Properly, the event should be one of the following: a call event, which is the name of an operation, possibly with the assignment of values to arguments; a signal event, which is the name of a signal, possibly with the assignment of values to the attributes of the signal; an any receive event, signified by the keyword all, which means any event will cause the trigger; a change event, triggered by a change in a condition; or a time event, which can be a relative time event, after some period of time has elapsed, or an absolute time event, which is at a particular set time. We can also show the start of a state machine using an initial pseudostate, which is a small filled black circle, and the end of the state machine can be shown with a final state, which is a filled black circle inside a black circle with white inside it. Let's draw a state machine diagram in Enterprise Architect. We'll start with a behavior state machine to model the behavior of the use case directly controlled device via browser. So I'll open that use case diagram, which is in the running package. Here's the use case. I'll right-click and select New Child Diagram, State Machine. I'll give it the same name as the use case. For some reason, which I think is how it's described in the UML specification, a frame is added into the diagram rather than only being displayed if the diagram is exported or used elsewhere. Other tools may or may not display a frame in this way. I'll add an initial pseudostate from the toolbox. I click in the toolbox on Initial and then on the diagram inside the frame. It doesn't need a name. I'll do the same for the final state. Now I'll add a state. Again, I click on the toolbox and select State, then click on the diagram. I'll call this Display Page. It represents the situation where the page for controlling devices is displayed. I'll enlarge it so that I can have other states nested inside it. Now I'll add some states inside it. The first is called Room List. This represents when the room list is being displayed on the page. The second is Device List, which represents when the device list is being displayed on the page. The third is On/Off Device Info. And the last is Open/Closed Device Info. And these represent when information about a particular device is being displayed. Now I need to add some transitions into the diagram. I'll add one from the initial pseudostate to Room List. I'll use the quick linker to do this. I drag across into Room List and select Transition from the context menu. This transition means that whenever the page is entered, the use case goes into the display page and the room list states. Let's go into the dialog for the properties of this transition. I can add three things here. First is the trigger, and I'll put in Enter Page. We'll come back and look at the type and specification in a later movie. I have to click Save the trigger. Some dialogues that contain lists of items still use this style of dialog in Enterprise Architect. It used to be used for all lists, including attributes and operations, before version 12. The next is the guard at the top of the dialog, and this transition doesn't have a guard. The last is the behavior, which can be written in pseudocode or program code for a language, or informally in this text box. I'll add display room list. You can see the label on the transition with the trigger Enter Page and the behavior after a slash. I'll add some more transitions. I want one from room lists to device list. The trigger is select room, which represents the user selecting a room in the list. And the behavior is display device list. I want one from device list back to room list. The trigger here is back, which represents the user pressing a back button or something similar to go back in the dialog. And the effect is display room list. I want one from device list to on-off device info. The trigger here is select device, and the behavior is display device data. In this case, I want a guard, as it should only go to on-off device info if the device is an on-off device. So I'll set the guard as device.class equals on-off device. So here we have a transition which has a trigger, a guard, and a behavior. I'll do the same for open-closed device info. I'll add a back transition for both of these with the behavior display device list. Finally, I'll add a transition from display page to the final state called leave page. This goes from the containing state because the user could leave the page at any time by going to another page or another website or closing the browser, and it doesn't matter where they are in the nested states. So we've created a basic state machine diagram with states and transitions and added triggers, guards, and behaviors to the transitions. We also have an initial pseudostate and a final state, and we've nested some states inside another.